All right, so let me get started. Marley Gray with Microsoft, and also the chair of the Token Taxonomy Initiative. I also sit on the board with the EEA and wanted to provide an overview of the Token Taxonomy framework itself. And a good bit of back end and background is helpful to understand what we're trying to talk about. First off, the Token Taxonomy Framework is the major output from an organization called the Token Taxonomy Initiative, which just so happens to share the same management, staffing, and infrastructure for the most part with the EEA, but it is a separate organization. It is not an Ethereum aligned or specifically aligned standards body, but rather it is neutral. And you'll see as we go through the Token Taxonomy Framework why that is the case. It has been broadly welcoming, really, to everyone, including all platform providers, because of its neutrality, including most of all the main ledgers in Hyperledger, the Ethereum variants, and things like R3, Corda, digital asset, Hedera Hashgraph, a whole bunch of others as well. But probably more importantly, it is probably most directly applicable towards non-technical business audiences that are focused on creating solutions, and tools being, tokens being one of the tools that they are one of the new tools that look to potentially solve some of their existing business problems and create new opportunities. So with that, let's quickly jump into what the taxonomy is, and probably just as important, what it's not. Its number one goal is to essentially create common ground for educating and establishing common terms and definitions across the ecosystem, so that we are speaking with one voice as an ecosystem. In blockchain category, doesn't mean you have to be a blockchain to use this, but it allows us to speak to business people and technology folks, and even, probably as importantly, regulators around the world, and speak and not confuse them with terms that are either specifically out of financial services or specifically out of blockchain, and create a framework where we can, everyone can articulate what it is that they're trying to do with the token, and talk about the business problems it's trying to solve. So from that, it establishes those common terms and definitions. And then underneath the covers, it is a composition framework. So it is built up of a whole bunch of different, what we call them, artifacts, and they're just essentially business descriptions with metadata for individual components, and I'll go through this in just a moment, that allow you to compose a token without knowing how to program anything, but rather understanding what the concepts are and modeling out what you would want your token to be able to do, and just as importantly, not do. And then it lets you create this token definition, which, as it turns out, is a really solid set of technical requirements and business requirements that can be used to implement that token for a specific platform. It does not tell you how to implement it. It rather tells you, if you're going to implement it, this is exactly what it should do. And then the notion behind that is, when you have that and you've written it to that specification, we can then eventually certify that that token implementation meets the exact specifications that are in the token taxonomy definition, and we call that the specification. Now, we have not defined the certification process to date. We have a start on that, but obviously there's if you've ever been in this business for a while, you have to first agree with what you're going to standardize on, and then how it's actually certified on each platform. The vendors and the actual platforms themselves will have to be able to lean in and help. Not only that, but you also have to have a way to actually certify and test it. So those tools are going to be in development for a while, but that is the long sort of arc of what that is. So what it's not is, it's not blockchain specific. It is not a legal framework or a regulatory framework, but it's great common ground. And it's by design not complete. It is intended to be a collaborative, very much community-driven, open source sort of ecosystem where the framework entices folks to contribute to increase the number of possibilities that people have. So I've done this presentation about 1,000 times. So I'm going to, now that we have some visuals to show, I'm going to actually show you what the end of the road might look like. This isn't what it looks like at the moment, but we're racing towards this. And what you can expect an experience would be from a non-developer business person that has gone through some basic training and maybe learned about the token and can begin to work with this framework to design a token. So here's a designer look and feel that you would look at. Looks very similar to most of these. Well, this at times now seems sort of old school, but if you've been around for a while and you remember how we used to have WYSIWYG UI designers where you would drag controls and plop them on a page and sort of create what your user interface would look like. This is the same sort of scenario where you would start out and pick from, you have these different palettes of token bases. These are essentially the starting points that you start with. And then you can grab from the various property sets, and we'll talk about what those are in a moment, behaviors and these things called behavior groups. Don't worry about what the terms are at the moment, but rather let's focus on what the intent is. So if we go through this, a user could come in and grab the single token or singleton token and drop it onto the design surface. And then along with that, automatically, some of these are pre-configured to have behaviors already attached to them. So this singleton behavior is actually already attached. You just don't see it until you drag it on there. And then from there, you start dragging. In this case, we're dragging property sets like the file property set and the bill of lading property set, or whatever these property sets are, and they snap in to build the properties out this way of what those would be. And then the behaviors we grab over here from the palette of behaviors, and we'll drag and drop behaviors to say, it is transferable, it is attestable, it's loggable. And then, we get to say save and call it bill of lading. So this is our bill of lading document token. So this is essentially we're going to be scanning in a bill of lading and creating a token out of it. And then describing, that we could transfer it, it's attestable, it's loggable. But we're not finished with that. We can go out and then add different behaviors. So here's another example where you would start with a fractional fungible. Fractional fungible means that it is subdividable. So if it's subdividable, when I drag fractional fungible, it automatically brings over subdividable. That's by definition going to be there. Then I would say, how many decimal places do I want this fungible token to be subdividable by? And I would have I could simply click on subdividable, click on it, pick the number of decimals, and then it would give me an example of what it looks like. Same thing for property sets. If I have a SKU property and I want to set a max length on the SKU, how would I do that? I could type in a number and then a regular expression would come into play. I wouldn't have to type the regular expression, but I could put in things like max length or put any other constraints that I wanted to and have that in the design. Now you'll notice over here, you could also do the same thing without having a pop-up window on the right-hand pane. I could change these properties. So it gives us a very sort of intuitive way. And I'm going to point out a couple of other things as I continue along with this. You can also use it for education. So you can simply hover over something, and if I hover over the SKU, it tells me what the definition of a SKU property set is. But also over here, I can see my token base is a fractional fungible. Here's the definition. And all of this text is coming from the framework. So the individual artifacts have all of this metadata in them. Within their graphical visualizations of them are these artifacts that are in the Token Taxonomy Framework. And it gives me description, gives me some examples. So I can use this user interface to surface the contextual information about tokens as a user is designing that token or learning about that token. So you could pull up an existing token example like Fab token or an ERC20 variant fungible that's given a business definition like a loyalty point, and I could hover over these and learn about that. What does this actually do? What does it mean as an education tool? So this again is various things are being in development. I'll point out some things here. You'll see this thing called a token formula. I'm going to go into all of these things in detail in just starting in the next slide of breaking this thing down. But I wanted to give you a feel for how we envision this being used in the non-blockchain community, but also it really should unlock sort of the concepts and the power across the broader ecosystem without sort of starting with chain code or solidity or whatever. Rather, let's go back and model out what we're actually trying to do, and put some real world language in there so that end users can understand these concepts.
Mm-hmm.
So let's start breaking this thing down. First, we have to define some predefined terms. We try to keep it at a minimum, and if you've been in programming for some time, these will look very, I kind of understand what these are, and they kind of make sense. But I'll start at the top. We have this thing called a template or a token template, which is actually a composite in itself, and it has two main parts. It has a formula, and then it has a definition. So I'll go into the details of those, but those two things combined create a template itself. When you write an implementation based off of a template and someone deploys that deploys that to a network, it becomes a class of that template type. So it's a deployed class, and then individual tokens, depending on if it's fungible or if it's a non-fungible, that is what we call an instance. So it's an instance of that class. So that doesn't translate exactly to every platform, but it's more of a concept in establishing these terms. So when I'm saying the instance, I'm usually referring to what an end user would think of as the token in their wallet, the balance that they hold. Those are instances of that token class. And from that token class is based off of the template specification of that. So that gives us sort of a set of high-level terms. And within those terms, we say, okay, let's use an analogy with baking. So a token class is like a cake, a finished cake. It's baked from a recipe, like a template. A slice of the cake is a token instance. You can have bigger or smaller slices. The cake is made of ingredients like milk, flour, sugar, and the like. That's the formula, right? The formula itself is just a list of ingredients. And then the definition are the specific instructions for how to mix the ingredients, how much of each ingredient is needed, how much milk, how much flour, how much sugar, when do you mix them together, all of those things, and then how long to bake it. So the template itself is essentially a recipe. It doesn't, now how you implement it, the analogy starts to break down when you start getting into the physics, but that's actually what we're talking about here. So, and the TTF ingredients are artifacts. Those are the individual milk, flour, sugar, things that are like standalone. They have the potential to have a quantity, for example, but they don't specify what that is until they're placed in context with other ingredients in a recipe, like a template. And then once you bake the template, that's an implementation class, and then the instance is a quantity of that class. Okay, so that's all sort of high-level stuff. Let's now break into what a template formula is. So this is where you'll usually start. A typical user would usually start, an end user would start with a template formula. So that means you're going to try to compose or get all of the ingredients that you would need, like we did in the graphical designer, starting with a base token and grabbing all the behaviors and property sets that met our needs to create a template formula. And as you drag those things across and plop them on the design surface, under the covers, it's building this formula. And it has the base type and the formula for more sort of classification purposes, which we'll talk about in a minute. They have symbols, and it looks like a mathematical formula, but it's very simple. It's just a way for logically grouping these things together and differentiate what's a behavior versus what's a property set versus a base of a token base itself. So you can see how the formula breaks out. And again, we're just talking about the formula here, not the definition, the formula itself. So those are visual symbols underneath the covers. Each one of these are artifacts, and they each have a unique identifier, which is just a GUID or a UID in the framework. And it has a type, so you'll see that in a moment. And then once you have a formula, then you can say, I want to create a definition from that formula. And what that does is it essentially goes out and because each one of these, a formula is just a reference to individual. So this is a reference to milk, flour, sugar, but it doesn't say how much each one. It just says you're going to need these things. These are just pointers or references. When you say I want to create a definition, it creates a new artifact called a definition, and it grabs essentially a copy of each one of these. It's called a reference, but it's essentially it grabs each of these things and puts them into a structure that you can then go in and specify. My subdividable amount is decimal places of 2. This is where you indicate what the settings are for that individual artifact in that context of the formula. That'll be very, very specific for the template that you're defining. So if you're defining a stable coin, it's, in the US or most countries would have a decimal place of 2, right? You're subdividable by 2. Is an example of that level of detail. So again, this is our definition that we're pointing to. So formula, definition itself. Down here we have classes. So you'll see that the token class, we use the same color to say, hey, it should have basically the same interface. It's just implemented differently underneath for different blockchains. So it also represents a common abstraction, which we'll get to in a moment. So that's the framework, basically how you sort of compose those things. And then you compose them of artifacts that are placed into categories. And these categories are the base tokens. Those are sort of your starting places. Property sets, which I'll talk about each one of these in detail here in subsequent slides. So property sets, you can think of just simple properties that have getters and setters and no heavy logic behind them, like a skew, for example, or a PO number or something simple. But behaviors are really where we see most of the action, and that's where you're going to either define a capability or a restriction and really put in some business language and perhaps regulatory or compliant information in there. And the behavior groups are just a way to group, create a template of behaviors that typically go together and have them pre-configured for a specific use case. So let's go through these real quick. All artifacts have this thing called an artifact, and all this stuff is essentially under the covers. It's at runtime, if you will, it's just using protocol buffers. So you'll use, when you're working with artifacts in a programming environment, you'll use it just like native objects or whatever programming language you're using. We serialize it all to JSON in the GitHub repo. So the TTF is hosted in a GitHub repo. And just so happens, Git is a really great place to do collaboration at this level, where you can have multiple people contributing, and we track all those changes because we're serializing to text. We can see what deltas are and manage the expansion of the framework over time. Anyway, these artifacts are just GitHub based. They're pretty simple structure. The folder structure is based essentially on these groupings, and folders are named, and then they have the latest version, and then subsequent versions can be uniquely identified. So you have multiple versions of the same artifact, and then reference different versions as you compose those things together. So it's a pretty straightforward, if you've done any tax, your framework-based work, it'll look and feel like any other framework. So let's go through some of these first, like the base token types. We have, you'll see the fungible tokens. You have this is going to get a little bit in the clear classification. I'm going to cover that much more in detail in the next slide. But here we have a common fungible, which is the tau F, and then the unique fungible, which is essentially balance or account-based fungible for common. Unique is UTXO. We think that same concept will apply to non-fungible in certain platforms. So we just said, okay, let's just let that flow over to non-fungible tokens, whether or not for an individual platform it makes sense. We didn't want to restrict it yet. We may over time say, this doesn't make any sense. It's confusing more people than it's worth, but we defaulted to not doing that initially. And then we have this notion of a hybrid. And a hybrid is the way you would model out from a business perspective, things like a security. So a mortgage-backed security would be a fungible parent with a bunch of child non-fungible, well, logically mortgages. Each mortgage is its own unique non-fungible, and then I can just issue thousands of fungible tokens to allow me to sell fractions of that pool of mortgages. You turn it on its head, and you can then model out something with a non-fungible parent, like if Metallica's coming to a city and they're going to do a three-day show. You would have a non-fungible token for each day of the show, and then you would have classes of tokens. One for general admission, those are fungible, and then you could have reserve seating, which now that they've gotten old, I guess you kind of want to do that for Metallica concert. You could, buy reserve seating and get like premier seats with, earplugs, so you don't go deaf in your old age. Anywho, reflecting a little bit too much of my last experience at a Metallica concert. So hybrids let you sort of model these things out. How they're implemented, it really varies by platform. But we don't want to restrict people's concept of building tokens based on what underlying platforms can and can't do. We didn't want to, by design, we did this very early on, as to say, listen, we don't want to bring any restrictions or capabilities and explicitly restrict the framework itself to not being able to have a concept just because it doesn't make sense for that platform. That's not the intention here, and we don't want to do that. So let's talk about classification. This is super important for once you start to understand this better. This becomes sort of really, really important. It helps you sort of guide customers and regulators as to sort of what the big picture is. So the first is the token type. It's either fungible or non-fungible. Those are the fundamental differences. I'm not going to spend time covering what those are right now. But from there, then you say, okay, what's my token unit? Is it fractionable, whole, or is it a singleton? A lot of people get hung up on the whole or singleton, and so isn't a singleton a non-fungible? And well, we've seen scenarios where non-fungible tokens can actually be subdivided. So I might have a non-fungible art token, but I could then subdivide that and say you own a quarter of the Mona Lisa without me having this weird multi-sig type thing. But the whole token itself is a non-fungible whole. Anywho, it's not an implementation detail. It is what is the unit from a business perspective. There should be one of these, only one, and it cannot be subdividable. So that's a singleton. Whole is essentially saying you're dealing with whole numbers. Fractional, we already talked about subdivision. The next one is value type, whether it's intrinsic or reference. So intrinsic value is a cryptocurrency. It's not backed by any asset, no real world asset behind it. So that is what we call an intrinsic. Reference is where we're seeing a lot of the action now, is it's actually referencing a commodity or a piece of property of some sort, or backed by a pool of, like Libra, backed by a pool of currencies. Anyway, that's a reference type. The second is, or the fourth, sorry, is representation type, common and unique. We just talked about this on the last slide, whether it's common, fungible, UTXO versus balance. If you say that to a business person, you're never going to get past the discussion. But if you go and say, hey, it's common and unique, what does that really mean? And we talk about properties and give them business scenarios for, like, if you have a whole bunch of tokens and they should all share a SKU number, and you have to change the SKU a year after it's been out there, that becomes a problem changing that SKU for all the tokens that are out in the wild if they're all unique. That's a business problem, right? It's not really there's ways to solve that, but you have to think about it up front. How would I address this, as you go forward? And the fifth one is the template type. Now, this is a template typing because when you're defining a token, you sort of define it as an individual thing. Then you can put it in parent and child relationships after it's been defined. Now you can then combine them and say it's a single token, meaning there are no child tokens, or if it's a hybrid, it can be a parent with one or more children, and a child token can actually have be a hybrid itself, which can create very complex model, very complex business scenarios. So these are the definitions. I just walked through all of these so that you guys are going to get these slides, so you'll be able to see the details here and read these. These are all in the markdown as well. That's publicly available in the documentation for the framework. But this is a good slide if you're trying to communicate it to a larger audience. So let's go into the individual artifacts. These are the individual sort of recipe ingredients themselves. So properties themselves, let's back up a little bit and talk about properties. Properties are either behavioral or non-behavioral. If you've been programming for some time, this makes a heck of a lot of sense. We have sort of a behavior, excuse me, a regular property set is just like a regular property, or a something that has just a getter and a setter, meaning you're going to set the value without a ton of logic, and you can get the value, and you're expecting that property to be queryable for an object of that class in a programming language, for example. That's what we would call a property set. It's kind of doesn't require a lot of logic to set the value. We'll talk about behaviors in a minute. You have behavioral properties that are not exposed, or they're dependent on a behavior to set its value. That's what we call a behavioral property. It should not be defined as a property set. So it's a sort of for people that haven't been programming for a long time, this is sort of you have to kind of figure that out. But for the most part, we're saying it's something like a SKU, who the issuing organization is, something like that. The denomination of the fiat currency backing the stable coin or whatever would be property that we would look at. So these things have a symbol of you'll see the fee SKU, which is essentially in the formula how you're there, and you go in there. So the most important thing there is when you're putting this in a token definition, you can set things like property restrictions. It could be 7 characters long. The first 2 characters are numeric, followed by a dash, and then the rest. So you would put expression, validation things in there to put business rules for those individual properties. Behaviors themselves, again, this is where the vast majority of we'll see. Well, I say that we think, well, this is where most people will pivot to, and they'll think about behaviors. They're either a capability or restriction. So something can be transferable or it can be non-transferable. Now that's essentially the same behavior, but one's just the opposite. And you'll see how we use the tilde symbol for that to indicate the opposite. And then a behavioral property. These are properties that are buried within the behavior definition. So if you have a property that can only be set by a particular behavior, that should be defined in the behavior itself. So we'll talk about subdividable has a decimals property. Now, how you implement it, again, this is just for the definition to make it readable. Now, the interesting bit about this is behaviors are also where we think behaviors and property sets are where you'll see we'll certify these things, at least surface level, because they are essentially describing the interface of the token, meaning what properties are exposed publicly, and then what behaviors are accessible out there as well. So when we describe a behavior and a property set, both of those, we have these things called control messages, and they're simple. You would say I have a behavior. This is how I invoke it. We describe it as messages. Transfer request has a transfer response. The transfer request requires these fields, and a response will include this as a receipt. And it is not a programming, but it does let people describe. When I'm if I've described a behavior, a property set like insurable, or a behavior called insurable, where I want to have proof of insurance on a bill of lading, for example, then the insurance company can define these are the values, or the consortium would define these are the values that we're going to prove insurable. When we insure a bill of lading, we call the insurable behavior. We're going to set these property values. So I'm going to pass in some cryptographic proof, identifier, certain things, and that'll be the insurable behavior. And they can define that, and they'll define those control messages. And then you can just apply insurable, to any type of token to say, it should be insurable, so it's going to expose this interface and have, set these properties. Not how it's done, but essentially this is where these control messages are describing. You have the option in the taxonomy. You describe them as very simple, a nesting of, I have a request and a response, and you just name the message and give it some optional parameters and what you expect them to be. Not what the values are, but description. The receipt should include a transaction hash and a block ID, or whatever you want to put in there. You have the option of also modeling that out in protocol buffer messages as well. Not required. Some people have done it automatically just to make it easy. But we anticipate control messages is where the majority of the focus on certification will happen. We come with a palette of a handful, more maybe 2 handfuls of common behaviors, and they're just pretty standard standalone things. So transferable is T, non-transferable is tilde T, so it's the opposite. Subdividable and whole is the same. So you'll see we're trying to reserve these symbols. A singleton is essentially saying that it's non-subdividable and it has a quantity of 1. Mintable, roll support, burnable. We'll go through some of these as we go through. So you'll have a sort of a rich palette of these available. Now, behavior groups are ways to grab a bunch of different behaviors and just pre-configure them. So we have one example in the framework called supply control, which has mint, burn, and roll support. And what it does is says, I'm going to model out the ability to create new supply and also remove supply. So that's mint and burn, but I want to enforce it with roll. So only certain people or people in a role or counts in a role can mint new tokens. So I'm going to grab roles in there, and I'm going to say there's going to be a group called mentors, or a role named mentors. However it's implemented, call it mentors, and that should have add member, remove member, and have a pre-check of is in role, and check that membership anytime someone calls mint. So if somebody calls mint, or it should check is the caller in role to do that. And that sounds kind of trivial, but this allows us to predefine that and have it be a behavior group that's instead of having to grab each one of these and reconfigure that again for that specific function, we just compile them together into this thing called supply control. Now, that's essentially the shortcut underneath the covers and the definition. You'll see all those behaviors, but they already have these settings set, so you don't have to do that work. Again, we talked about referencing a lot. One of the main things we try to do in the taxonomy is not duplicate data. As well, you try, you remove as much duplication as you possibly can. When somebody gets to a definition, it's sort of, and you're pulling over the artifact itself, it's essentially copying the basic values or things that had values, and then you could change them in the definition. In some sense, you'll have some duplication there. But if you don't change a value in the definition, it has no value set, or it sets to the default, it'll just stay with whatever the default is in the base artifact itself. But anyway, a reference is just that reference. Here it's not just a pointer to the artifact, but it actually lets you set the values that reference the actual artifact itself. So here's our template formula. We already talked about this. This is sort of walking through that same concept where template formula, again, is just a list of ingredients, but then from a template formula, you create the definition. And this is where you're getting the individual references to the individual artifacts and putting in the values for each one of those that apply to the artifacts in context for that formula. The token specification is a document that's generated. You don't create a token specification. You create ultimately, the token specification is created from the template definition. So the template definition has a unique ID, just like every artifact has a unique ID, and you can say, hey, print the tokens or create a token specification from this definition ID, and it will generate an open XML document that you can then open in Word or Google Docs and print it out. You can save it to PDF, whatever you want to do with it. But it is generated. Again, if you see something, you print this thing out and you see typos in it, because Word's really good at catching grammatical errors and stuff like that. Don't change the specification, go change the definition, because it came from your definition. And you might have to say, oh, it's not actually in the definition, it's actually in the artifact. So you would need to like crawl back to the artifact itself and say there's a typo in your business description of this behavior. And I can make that modification in my tool. And what it's doing is it's modifying your local Git branch, and then when you issue a pull request, we'll see that essentially go, oh, yes, let me fix this typo, or made this sentence read better, and that's just going to improve the overall quality of the framework. But essentially, that's what a specification is. It's a printed, human readable format, and all the tools that I'll be talking about, I'm going to show you in a minute, come in the framework itself and are self-contained. Here's some just rules on grammar. I'm not going to dwell on a lot of these. You can read a lot of these things in the documentation. I'd rather get to Q&A as quickly as possible, leave as much time there. But you can see these are rules for how we create the grammar itself. I've had lots of Microsoft research is like enamored with this grammar, and they're running wild with this, because you can do all sorts of things with code generation, formal verification. But it's actually quite useful. We primarily use the formula grammar just for classification and for visualization, and how you sort of visually create these things. I'll show you what these things look like in a moment. Here's just some more grammatical rules. Like, you can state a behavior is incompatible with others. Some are just obvious, like you can't be transferable and non-transferable. It's just you're either one or the other. But you might have some that behaviors can influence other behaviors. Like, they don't make sense standalone, and that is like one called delegable is an example. So delegable means that I can delegate another behavior that I apply delegable to another party to do on my behalf. So this is typically, I'm going to give my broker, they can transfer on my behalf up to a certain number of tokens without going through some business process. That's what we call delegable. Delegable makes no sense by itself. It has to be applied or influence another behavior. So you'll see that. Here's the classifications. We start things and we build these natural hierarchies where you have this sort of generic base token. It's abstract. Nobody creates just a base token. And you have branches, fungible, non-fungible, and hybrids. And from underneath each of those, it will branch out till you get to actual definitions themselves, and you can visually see how a fiat currency relates to a stock, what are their common parents and things like that. None of this is like actually the hierarchy is dynamic. You can pivot it and create new trees visually from the metadata. So we're seeing all sorts of interesting ideas, and I'll show you some examples of that in a minute. The hierarchy itself, we just use we start with branches that start with the fungible, non-fungible. We initially started with just fungible, non-fungible, but we said, you have to declare what is a subdividable capability sort of up front. So let's just cut to the chase and not confuse everybody with all these different bases. And so we said, we'll create 5 bases, and you have fractional, fungible, and whole fungibles. You have non-fractionable, whole non-fungibles, and fractional non-fungibles, and then singletons. And then you have this hybrid, which could be any combination of those in parent-child relationship. The branches from there sort of visually go out and say, what is your base token? And if it's a hybrid, what is the parent base, and what type of it is that? So then this just goes, and again, how the hierarchy is built. This is more for people that want to create new visual hierarchies and pivot on perhaps unique versus common. You pivot the tree like that as well. The token templates map to individual definitions themselves as a part of the template, and you'll see like End users will see physical names. Underneath the covers, it will have a reference to its parent formula. Here's artifacts are structured hierarchically. This is the visualization of the folder structure in GitHub. So it has an artifacts folder, and then it just has subfolders for the different classes. And you'll see each folder itself will have the latest, which is the latest version. They have individual version folders itself. The tooling and metadata has some interesting stuff built in there as well. Each artifact has what we call a set of maps, and those maps are essentially pointers to either source code for a particular implementation, could be finished solution, could be like a behavior can point to a source code snippet, like on Open Zeppelin or somewhere like that, or it can point to a finished source code that completely implements that, or to a solution. Maybe it's something on AWS or Google that you've already set up and it's ready to go, or it's your solution that you've got ready. Somebody can discover your implementation just by using the tools and get to the framework itself. And then the other type of reference is something called an artifact resource reference, which could point to regulatory guidance, for example. So if there's regulatory guidance for a stable coin, we would have individual mappings to the regulatory guidance, maybe by jurisdiction, SEC, MAS, whatever we would have. We would map that in. So maps, you can have those rich, and that's really extensible. You can sort of do whatever you want to with it, and we anticipate that that becomes in handy for things like CodeGen as well. So if you're going to start building tools off of this, you could create metadata and submit it, and have it be in the framework itself. The model, when you get it, so we get sort of to the when you can actually grab the entire object model and then navigate it like this. So I can say, give me the whole taxonomy at one go, and it will return back depends on your platform, like if it's in Java or C# or Go, you'll get an object that has a nested list of these objects or collections, and you can just navigate through this and look at these objects themselves. You don't need to worry about reading JSON or serializing it. Just use the programming interface and protocol buffers and as a gRPC interface on the front. Pretty straightforward, really easy to use. One of the things that I'd like to talk to people that have been doing this for a while is to sort of say, when you start declaring things like financeable, doesn't mean that your token is going to implement finance logic, but rather it's indicating that your token will support being encumbered or attached or related to a contract, either on the same blockchain or some other completely different system. And it will have the hooks in there to support the essentially cryptographic linking of a token to some other legal contract or something else somewhere else, so that you can quickly correlate those and trigger those and encumber things. So I could have the financial behavior on a property title for a loan contract that's on a completely different network that you can't get to, but I will not be able to trade or burn that property title because it's encumbered using the financeable behavior. So the loan contract would have to go in and remove that encumberment by whatever the business process is in that loan contract. So it's really a way to define these contract interfaces. Now, they're not purely contract interfaces, but that's more of a concept we're trying to get people to really hammer home that tokens are not contracts and contracts are not tokens. It shouldn't be. Now, they might be implemented using the same technology. You might say, oh, this is like on Ethereum, it's a token contract. Well, it's not. Okay, tokens are contracts, technically, but it's confusing to the rest of the world. So we don't want to do that. We want to say tokens are this concept. Contracts typically will dictate the rules of how we transfer or utilize contracts or tokens as mediums of exchange or value between ourselves. So let's not commingle those things together. I'm about to wrap up here. Here's an example of the classification hierarchy. This is a dynamic view. You could sort and pivot this however you wanted to. There's the old design. You saw the new design. This is actually this is what it looks like. We have some different tools in the works. we describe a workshop process where we want partners and members, industry organizations to use the TTF as a place to record the outcomes of a workshop. We don't describe how you do a workshop. That could be a pre-sales engagement. It can be a exercise and a meetup for a vertical industry group. But you would go through and you can define individual artifacts and then record those in the token taxonomy tools so that you can contribute them and have those be reusable. So that becomes like in the insurance industry. You want to define the insurable behavior and these properties that are valid for insurance so that the supply chain groups will just reuse those artifacts so that you'll get the goodness across vertical groups. This is the last slide before we go to Q&A. The TTF ends where implementation begins, essentially. TTF essentially stops at the specification and definition, and then it has links to where you can point to implementations, whether it's source code, the implementation, or reference material. So with that, I'll stop. I do have some, you'll see appendix slides, but I wanted to leave time for questions.
Hi, this is Jim Mason. I unfortunately arrived late to the presentation, but this thing is fantastic as an architecture. So if you look at it, what's brilliant about it is you've modeled beautifully in the formulas. The taxonomy has modeled very well what I call the behavior side of life for different token use cases. And what that does is, because then the metadata, in a sense, exists as a definition, it provides the opportunity brilliantly to automate a lot of the from the model onto the actual implementation, which is excellent. So thank you very much.
No, thank you. It wasn't, it's a community effort. So I anticipate the folks on the call, we want you to help us do this. And this is like call to action for everybody. It's like lean in, help us out here.
Okay. This is Manny from SwapSub. What kind of a tooling is available, or at least in the early stages, for modeling these things?
Very good question. So we have when you clone the GitHub repo, when you first clone it, there are tools in there. The first is you'll see the raw artifacts folder, and don't go there. I mean, unless you just really love editing JSON directly. Rather, we have an object model defined in a separate folder. You can navigate this. Just all clearly documented. But there are tools in there, and one is called the taxonomy service. The taxonomy service is essentially a CRUD, create, read, update, and delete, gRPC service that you can stand up, and it will essentially load the taxonomy. So when you clone it, it will load from your local artifacts folder and create the object model. We call it the TOM. And the TOM is essentially that structure we showed. And then you can just make a single call to that service and say, hey, give me the whole TOM. When it's local, it's not that big a deal. You can get the whole thing and have it in memory. And when it's in memory, we show you the client. We have a sample client that goes through and creates new artifacts. You can modify artifacts. You can create a definition from a template, and you can print specifications. So the ability to print them. So we have the basic object model, the service that serves up the object model, and supports reading updates and deletes to that. But it does it to your local copy. So if you accidentally delete a bunch of artifacts, until you issue a pull request, nobody else is going to see it. So you can shoot yourself in the foot and delete it and start all over again if you want to. So that's a good thing. And then so it has that with a sample client. That's more the lowest level, where we'll soon have. I was hoping to have it this week. It looks like it might be next week, but there'll be a browser interface, very simple taxonomy browser that's essentially read only. So someone can go and look at each artifact and read them without having to clone the repo or browse the GitHub repo and look at each artifact in JSON, which is not a really pleasant experience. And that's one. And then the other tools that are in development are the visual modeler that you saw. Microsoft, we're building one here at Microsoft for Visual Studio Code. That's actually we want it to be reusable, and we're donating that into so you could host it in your own website. You don't have to use Visual Studio Code. It's just a set of React pages. So we're sort of contributing to that. And then we have other partners. So we're trying to create an ecosystem of people using this as tooling, because once you have the gRPC service up and running, you can grab the taxonomy object model on any platform, whether it's web, Java, Go, .NET, you name it, and then do whatever you want to with it programmatically, because it's very easy to work with at that point, and create your own tool. So we've had some people think of the printer as a tool that's just using the Open XML object model to create Word documents or Open XML documents themselves. So those are the tools we've sort of put a call to action to the tool manufacturers or tool makers. We have 3 projects in flight right now. The one in the TTF itself for the web application. We have one in the Visual Studio Code team, and then we have one that is actually has some tools around the workshopping that a company called Envision Blockchain has been building around sort of the process itself, but also you're looking at building tools to facilitate workshopping itself.
Mm-hmm. Hey, Marley.
It's been a great presentation. Thank you for coming. I have a couple of questions. One is, you did mention that parts of the roles definitions, which would have identity implications. I would ask you to present on the identity working group on those topics. The other thing is, you mentioned that there was a reference token and another kind of token, but reference token implies some kind of a real world interaction. So would you say that you need some kind of custodian or something like that to implement that reference token?
No, the reference versus value is, the value is reference versus intrinsic. So it just simply means the value of the token is referenced elsewhere. The token itself by itself is not.
I understand.
Yeah, that's it. And we didn't take it any farther. We want people to define sort of custodial behaviors or behavior groups, and that's we're encouraging people to look at that, and we have lots of people rushing to custodial implementations without really defining what does it mean for custodial services. And I think that's an awesome exercise that somebody could use the token taxonomy to model the business process after. Hint, hint. But I agree with you. That's a huge area.
To follow up on that is that we are part of the I'm not sure if you have noted the common domain model for the capital markets. So where we go through all these details of contracts and how these contracts are defined in the real capital markets world, and definitely I see at some point where there's an actual transfer of value comes in, the token taxonomy and the artifacts is very, very useful. I had actually asked some of these working group members to participate. So I think at some point we would like to reach out and see how this could be incorporated into the CDM modeling, into a CDM modeling itself.
Yeah, I think the same way. And we purposely sort of really, when we scope this out, we said this is not about contracts, right? It's just tokens. And that is the work that they've done. Is actually, we would want to have this be integrated with.
Right.
They complement each other nicely. Yep.
Yeah, at some point, I probably would like you to come in and just give a quick intro to the working group, so that could kickstart the effort of integrating the contract work with the tokens. You guys have done a great job.
Great.
And the last question is, how do you see Hyperledger, the Hyperledger community interacting with this particular effort at PDF?
Very good question, because we don't deal with implementation. There are a couple of things that we would look to do is we're very interested in creating frameworks, implementation frameworks for how you would, so a lot of the certifications for creating, like if you create a token spec, how do you certify it for Hyperledger Fabric? We think should be a project within the Hyperledger Fabric community to say, hey, we've got this, and then perhaps provide wrappers and starters and SDKs for creating TTF compliant tokens on Hyperledger 2.0 or Fabric 2.0, or we have a product called Azure Blockchain Tokens that we just announced, and it's all about this as well. It's not about defining tokens, but how do we create a snap-in model where anyone can write a token for any platform, whether it's Hyperledger Fabric or R3 Corda, or but have a common interface. And so that's one that we've said when we're ready, we want to do this, and we'll do that in the Hyperledger Fabric ecosystem, because it's an implementation that we want to have everyone sort of come into. So we haven't formally proposed that, but that's we're really close, and because we think that's super important.
And you're right.
I'm sorry. I think we have to close the meeting now, because I think some people from the next meeting are already here. Sorry, Peter, I saw your hand up at the last minute. We will interact with Marley on the mailing list or somehow in an asynchronous manner. I'm going to stop the recording, and I'm going to ask, I'm going to thank Marley again for appearing and giving such a lucid explanation of a very complex topic. Thank you, Marley.
Thank you.